What is the Higgs field, and why do physicists say it gives mass to the universe? To understand this mysterious concept, imagine empty space not as truly empty, but as something filled with an invisible substance. That substance is the Higgs field, a fundamental field that exists everywhere in the universe, even in the deepest vacuum of space. In modern physics, particles are not just tiny solid objects. They are excitations of underlying fields. The Higgs field is one of these fields, and it plays a unique role. Unlike electromagnetic or gravitational fields, the Higgs field has a non-zero value everywhere. This means that every particle moving through space is constantly interacting with it. So how does this create mass? When certain particles, such as electrons or quarks, travel through the Higgs field, they interact with it strongly. This interaction resists their motion, and that resistance appears to us as mass. Particles that interact strongly with the Higgs field become heavy, while particles that barely interact with it remain light. Some particles, like photons, do not interact with the Higgs field at all, which is why they have no mass and always travel at the speed of light. The idea of the Higgs field was proposed in the 1960s to solve a major problem in particle physics. According to theory, particles should have been massless, which clearly contradicts reality. The Higgs field provided an elegant solution, explaining how particles could gain mass without breaking the fundamental laws of physics. In 2012, scientists at CERN confirmed the existence of the Higgs field by discovering the Higgs boson, often called the God particle. The Higgs boson is not the field itself, but a tiny ripple or vibration within the Higgs field, similar to a wave traveling across the surface of the ocean. Without the Higgs field, atoms could not form, chemistry would not exist, and stars, planets, and life itself would be impossible. In many ways, the Higgs field is what makes the universe solid, structured, and real. Understanding it brings us one step closer to answering one of the biggest questions in science: why the universe exists in its current form.